Hello and welcome to this channel. My name is Emmanuel Kwabena Osei and I'll be taking you through a course. But before we go through, let me ask you, do you know if the internet goes down for a day, just a day, approximately 2 billion emails and 3 billion Google searches will have to wait, right? Including your own. So if you want to search something on the internet, meaning that if there is no internet, there's basically no way that you can send the email or search for whatever information that you want to. And basically, we know that the internet consists of 5 billion computing devices. Wow, that is quite a number. 5 billion computing devices, including your mobile phone, your smartphone, your smartwatches, computers, modems, switches, routers, hubs, access point media. All these are basically part of this internet that we all enjoy. So what makes up the internet? All right, the internet consists of different kinds of computers that are connected together and other devices, as you say, modems, mobile phone switches, routers, and other things. So basically, these devices connect, then it forms what they call the global network. You are going to look at computer networking. So with this few minutes that you spend with me here, we're going to look at computer networking, a brief but comprehensive insight into computer networking. This course outline is divided in three sections. It is divided into three sections. So we basically be looking at the concepts under networking. Then in section 2, we look at types of networks. Then in section 3, we dive into network topologies. You look at what it means. Basically, you'll be asking yourself, what will I learn? You will learn a lot. In this brief encounter, you learn a lot. So let's look at the course objectives. By the end of this course, you will be able to 1. Explain the concept computer networking. Then 2, you will be able to explain the types of computer networks based on the size, topology, functional relationship, and protocol and media type. That is, you look at types of computer networks under size, classification under size. You look at computer network is defined as a system that connects 2 or more computing devices, transmitting and sharing information. Computer network is defined as a system that connects 2 or more computing devices for transmitting and sharing information. Then computer network can also be defined as an interconnection of various computers. So if you have your own computers, you have your own computer, I have my own, you connect it in order to share software, hardware, resources, and data through a communication medium between them. So with this communication medium, we're looking at what they are. We have the routers, we have the switches, we have other communication medium or transmission medium that we use. You can also use fibers, it can be wireless. Then the third definition looks at the computer networking as a set of autonomous computers, that is basically independent computers, that permits distributed a computer networking can also be defined as a set of autonomous computers that permits distributed processing of the information and data and an increased communication of resources. Then the last definition I'll be looking at says that a computer network can also be defined as 2 or more computers that are linked in order to share resources such as printers, storage devices, and other drives. Then they are also to exchange of files and allow electronic communications. The computers on the network may be linked through cables, telephone lines, radio waves, satellites or infrared light beams. And basically you can also have the Bluetooth devices. You can also link computers and it will form a network. Now these are some of the network devices. We're talking about network devices. We have the firewall, the router, the hub, the switch, the WAP. We have the NIC card and other components. So we have them here. So these are the 2-port repeaters. This is a modem, ADSL modem with Wi-Fi. And then this is a hub. So basically these components or these devices are used to connect other computers. This is a gateway, this is a router, this is a switch, this is a repeater. Basically all these devices are network devices. Then these examples of computer networks. So when you look at this, we look at these diagrams here. This is a computer network. This is a computer network. There is another computer network. So we have the desktop computer here. We have the laptop. This is a tablet. These are smartphones. And this is a switch. It can be a repeater. It can be any other thing. Then it's connected to the internet. So basically this is a network. And we have networks in different forms. We're looking at the types of networks based on the topologies, and you understand this more. You have different arrangements. This is a ring, this star, mesh. You'll be looking at them very soon. And thus ones are all types of or examples of computer networks. So if you have your computer, I have my own. Basically we want to share information. We look at all this. We connect the devices and then you have a network. Now let's look at reasons for setting up a network. So I have my computer or have computers. Let's say we have computers in the schools, we have computers in our organization, and we want to set up a computer network. What are some of the reasons why should we have a computer network? For example, in our school. Some of the reasons include, you may have so many reasons, but some of them include the network allows for information sharing. Basically, the network is about communication. So if I want to share information to other computer users or maybe somebody elsewhere or within the same school or within the same organization, I have my phone, I have my computer, I have my, let's say the tablet, and I want to send the information to somebody, then there's a need for us to have a connection. I must have a connection with a person. You connect the devices. And don't forget, the network is not basically about only desktop computers or laptops. These smartphones, our tablets and other things, they are also connected in this kind of network. So whenever you connect, you share information on social media and whatever platforms, it is through network. Don't forget, network is about communication. So network allows for information sharing. So the main reason, or one of the main reasons why you have to set up a network is to allow for information sharing. Then we also have resource or hardware sharing. We have resources such as printers, storage devices, and other applications. For example, when you go to the banks, there are so many cashiers, other workers, and within the same bank they use the same printer or one printer. It has been networked or it has been connected to the other computers. So about 4 or 5 people or computers can access the printer at the same time. Reduce that kind of cost. Then there is a collaboration. Does you have multiple people working on the process collectively? Yes. So we have a network. Basically, we can share informations, we can collaborate, we can come together and then work on one project at the same time. Then there is a reduction of cost storing information. Yes, we share information, we do this. You can use the Google Drive, the cloud storage, you store information on it. This will save your storage capacity. Then there's file sharing, which enable users to share data files through a network. Application sharing, which enable users to share application through a network. So if I have a file on my computer right now, and there's somebody somewhere that needs a file or application, basically I can send it through transmission medium. So these are the reasons why we set up a network. Basically, I know you may have other reasons, you can add them up. Now let's look at the advantages and disadvantages of computer networking. What are the advantages? We look at the advantages of computer networking first. One advantage of computer networking is that it improves information accessibility and communication. Gone were the days when you need information unless you travel miles to access that information. But now with a click of the button, you have so many informations at your own disposal. Now if you want to communicate with somebody somewhere, because most of the devices or almost all the devices are connected in the network, you can send information easily through computer networking. Then there's a high level of security. They have high connectivity or higher connectivity. As the internet or the computer networks help us to connect to different kind of people, computer users, every day, everywhere, at any time. Then there's a better collaboration. There's better collaboration. With computer networks, you can have different kind of people or multiple people working on one project, and it makes collaboration very, very easy. Sharing of ideas, sharing of intellectual works and other resources to help come out with a group or team project. Then computer networks has made it easy to share knowledge and ideas. Yes, basically, as I said, when there is a better collaboration, when there is a better accessibility, there's easy sharing of knowledge and ideas. People working on the same project can easily share ideas and stuff. But looking at all these advantages, one may think that computer networking do not have a bad side. It does have a bad side. One of the bad sides of computer networking, of which we term as disadvantages of computer networks, is virus and malware. There are so many different kinds of it which may attack our computer systems if we are connected to the networks. As we share applications and share resources, those viruses and malware that has the ability to duplicate themselves can easily attack our files and then corrupt them. The disadvantage is complexity. The networks are very complex, they said, and setting up networks, in fact, it needs experience and expertise. You need somebody who has knowledge and is well equipped and experienced in the field of networking to be able to set up a network and even in its usage. Then computer networks also create vulnerability of accessing the computers remotely, that is from different kind of sources, different kind of places, especially if they are connected to the internet. With this potential new method of accessing the computer, it can introduce new vulnerability. When talking about vulnerability, it simply means that like your computer is susceptible to viruses, to attacks, to all different kinds of attacks on the computer system or security issues on the computer system. People can easily have access to your files, your files can be easily attacked by viruses. And another disadvantage of computer networks is its expensiveness in installation. It is very expensive to install. Yes, because you have to acquire cables, routers, switches, and it's not easy for very small businesses or institutions, schools, to acquire all these kind of devices, the cables and other devices that are needed to set up or to install a computer network. So it has a high price tag, of which most of the schools and small businesses cannot easily have that kind of money to purchase all those kind of devices, including the software that is needed to run. Another disadvantage of computer networks is server failure or the service failure. We all know that a server is a computer device or a program that provides service to another program or its users, which we also call the client. Although servers do not frequently fail or are not susceptible to failure, but anytime the file server goes down, then the whole network comes to a halt. Let's move on quickly to section 2 and look at the types of network. So I welcome you to section 2 of this course. We are looking at types of network. By the end of this section 2, you should be able to classify the types of computer networks based on size, topology, and the media. Then you discuss the media used in network transmission. We look at the types of computer network based on size. So we talk about size. What are you talking about? Basically, we are referring to the catchment area or the area in which the network can be accessed. So the Cisco, we are looking at the first type of network under classification by size. And that is local area network. We look at local area network. The Cisco defines local area network as a collection of devices connected together in one physical location, such as a building, office, or home. So let's say within the same house, within the same school, within the same office or building, then all the devices they are connected in order to have access to information on those computers, the resources, sharing of the resources, and other applications on the other computers. We call that kind of network local area network. And the LAN can be small or large, ranging from a home network with one user to an enterprise network with thousands of users and devices in an office or school. Well, this means LAN's unique characteristics, or the character is that it connects devices that are in a single limited area. So at the comfort of your own home, if you connect your computer to your mobile phone, you connect your tablet to your mobile phone, or you do all the kind of connections, your printer, or you have a hub, you have a switcher, you have a router at the house, you do that kind of connection, you call it local area network. Examples of local area network include networking in schools, networking in a laboratory, networking in a university campus, networking between two computers. So you can cite more examples. So let's look at something like this. This is a server, this is a hub, this is a Wi-Fi router. So if I connect this and this alone, even this alone, serves as a computer network. So that is the local area network. Now another network under classification by size is metropolitan area network, normally called MAN. MAN is generally seen as several LANs interconnected by dedicated backbone connections. So when you have several local area networks, we connect them together, we call it metropolitan area network. So it is a network that is geographically larger than a single building local area network, but is located in an area that is smaller than one area wide than a wide area network. It usually covers an entire city or a large campus. So let's take, for example, a town or maybe a metropolis. Different kinds of government offices have a connection, or they connect all the computers in the government offices, the district assemblies or the municipal assemblies. They connect the computers at the judicial services to those computers. They connect the computers at the various schools together. We call this kind of network metropolitan area network. Don't forget, the size determines what kind of name you call it. If it is geographically smaller area, it is called local area network. But if the geographical area is quite bigger than the local area network, we refer to it as metropolitan area network. MAN often acts as, so basically when I say MAN, I'm talking about metropolitan area network. They often act as high-speed network that allows sharing of regional resources and provide a shared connection to other networks. This form of metropolitan area network is called wireless metropolitan area network. Basically what we are talking about is that we can have metropolitan area network that is basically wireless. Well, when we look at this building here, so let's say basically this is the metropolitan assembly. This is the judicial service local area network. There is a municipal assembly area network, and this is the residency of the government workers, and let's say this is a hospital. So we connect all these networks together, this local area network, local, to form a larger network, which we call the metropolitan area network. Now we move on to look at the wide area network. Wide, as the name implies, wide means that it covers a large area or geographical area. The wide area network, which is also called WAN, is a technology that connects your offices, data centers, cloud applications, and then cloud storage together. Or maybe your mobile phone that you are using. We have schools and other users also here, repair facilities, motorways. Somebody might be in the vehicle and still be connected to the network. So all these people, all these networks comes together to form the wide area network. Now let's look at types of computer networks based on topology. Types of computer networks based on topology. When we talk about topology, we are talking about the physical arrangement of computer devices in a network. That is basically what topology refers to. Now, computer networks are classified into star network, bus network, ring network, mesh, tree, and then hybrid. A star network is a type of network that uses a central device such as a hub. We look at examples of the computer devices. This type of network could be a local area network in terms of size. Yes, so in terms of size, we can have the local area network, which is also a star network. We're looking at this into details in the next section. In this regard, a network that belongs to these two classifications can be referred to as star local area network. So if it is a star network and it's also a local area network, we call it the star LAN network. It basically means a star arrangement of the cables and computers in the local area network. Then the second one I'll be looking at is the bus network. It only has one cable that connects all competing devices on the network. This mostly happens in local area networks. They are referred to as bus local area networks. So a bus LAN is a type of local area network that is implemented based on the bus topology. So we'll be looking at the bus into details very soon. Then another type of network under this topology is the ring network. As indicated earlier, the third type of network based on topology is ring. We all know what a ring is and how a ring looks like. So in ring networks, all network devices are connected, or network so all the network devices are connected using cable, which forms a loop, which forms a ring around. Data moves in one direction, and there is collision of data in this kind of network. When the local area network is implemented based on the ring network or the ring topology, we refer to it as the ring LAN. Then we have the mesh network under the topology. Mesh network is a kind of network that is implemented using the mesh topology. In such networks, devices are connected among themselves in such a way that two devices have a point-to-point connection, meaning that one device will be connected to different kinds of computers. They don't have a central device that serves as the server. One advantage of such network is that there is redundancy in terms of connection, which ensures that connection between nodes or devices are always up and running. Nodes or computers have more than one route to their destination. Yes. Meaning when you want to send information to one computer, there's no need to pass through other devices or other nodes before. This kind of network can be implemented on the wide area network. A network that has the characteristics of a mesh and LAN is referred to as a mesh LAN. We can also have mesh 1, that is wide area network. Then look at a 3 network under this classification of topology. We define 3 network as a kind of network that is implemented based on the 3 topology. You know how a tree looks like. It has branches. It has the main stem before the branches and other things. This can also be referred to as extended star topology. 3 networks are mostly found in schools on campuses. Yes, a local area network or campus area network that is implemented based on the 3 topology is known as the 3 LAN or the CAN. That is the campus area network. Now let's look at classification of networks based on functional relationship. We learned in the previous sessions that computer networks can be classified by topology. Yes, we learned that it can also be classified by size. Now, we are also going to look at classification based on functional relationship, which can be classified into client-server and then peer-to-peer architecture or model. Client-server network model is basically about having one computer, which is called the server, which is the central device that provides services for the other computers on the network. The other computers on the network are also known as clients. So I have my computer, I have my laptop, I have my... It's centered on this device or computer, and that device is what you call the server. And the other devices that are taking those kind of services from the central device, you call them the client. So the server provides services for its dependents or clients. In network computing, a server is a computer or node that provides services for the clients on the network. This creates a relationship known as the client-server relationship, also known as the server-based network. Yes, so the client-server networking model or architecture is, without question, the most widely implemented model, and the one you are most likely to encounter when working in real-world environment. Then look at the peer-to-peer. Look at the peer-to-peer network model. A peer-to-peer network is a decentralized network model offering no centralized storage of data or centralized control over the sharing of files or resources. So what happens is that if I have a network, or there's a network within my institution or school, all the computers are independent computers that have their own resources, that have their own files, that have different data on them. So in order to access them, you have to directly have contact with them without any central device serving as a server. So all the systems on the peer-to-peer networks can share the resources on their local computer, as well as use resources of other systems as and when they want to do so. In other words, the nodes equally participate in data sharing and divide all tasks between themselves. So the nodes interact with each other as required and share resources. So the communications are direct. So let's say this computer one going to access information on this computer. There's no central device here or server here, so it has to communicate with the laptop here direct. If this node wants to communicate to this, it has to communicate direct, and vice versa. So that is what they call the peer-to-peer network model. Now let's look at the types of computer networks based on media type. Media type. On the media type, you have the wired network, then the wireless network, then the fiber optic network. Now let's look at the wired network. This is a type of network in which physical cables have been used to connect nodes or computers on the network. So the wired network almost always uses a central connection device such as switches or hubs. All kinds of wire networks come under this type of network. Examples include the fiber networks and then the twisted pair network that I'll be looking at very soon. So use cables to connect them. Then you have the wireless network. Wireless means that there are no cables, there are no physical wires, the cables to connect or link the nodes or the computers on the network. It transmits and receives signals broadcast through the atmosphere. This type of network makes use of microwave, radio, infrared to transmit signals. We'll look at the diagram here. If I want to send something from this device to the tablet, if I'm connected to a true maybe mobile data network, or I can even use a Bluetooth, I can connect using this router here. I can connect my smartphones, my desktop, without necessarily connecting cables or fiber optic cables or any kind of cables to it. Then I have access to the internet. This kind of network is what we call the wireless network. That is a wireless. And look at the fiber optic network. And basically we are talking about network. This an example of the wired network that we just talked about. A network is termed as a fiber network when its main cable used for connecting computers and other devices on the network is fiber optic cable. The fiber transmits signals between the network device using light. When we look at this, there are different kinds of computers that are being connected, different kind of desktop computers that have been connected in order to access resources on them. Then we have the twisted pair network. So this is the twisted pair cable. This is how it looks like. Then the twisted pair networks are a type of network that are implemented using twisted pair cables or coaxial cables. They are sometimes also referred to as the Ethernet networks. That is all about the types of networks based on media type. We say we have the wired, we have the wireless, and under the wired we have the fiber optic network and then the twisted pair network. That is based on the kind of cable that is being used. I welcome you to section 3, and we are going to look at the network topology into details. So by the end of this session, you should be able to explain the meaning of network topology. You should be able to describe the 5 types of network topology outlined in this section. So let's look at what a network topology is. A network topology is the arrangement of computer systems. So the arrangement of the computers, the physical arrangement, as some books defines it. It can also be defined as the connection of computer devices to each other. Topologies may also be defined as both the physical and logical aspects of the network. Both logical and physical topology could be same or different in the same network. In this section, we discuss the physical topology of a network. And under this, as we already discussed, we have the star topology, we have the bus, we have the ring. We're taking them one after the other and look at what it means. Now we look at the star topology. The star topology is a type of topology where all the hosts are connected to the central device known as a hub device or a switch using a point-to-point connection. Thus, there is a central point to which all the hosts are connected. This means that with the star topology, let's take a quick look at this in the packet tracer. This, app we call it the packet tracer. It's a simulation app of which you can use to create a network. So look at this side here. This is what we call, we have the routers here, we have the switches, then we have the hub. So let's say I'm using the switch. I want to create a network. I select a switch here. This is my switch as a central device, which is a server. Then I want to have a network. These are the end devices. So I have my desktop computer here, PC1. I have my laptop here. Can even add another computer here. Let's say I have my printer here. There may be another computer. So let's say this is the server. These are my central devices. Sorry, these are my nodes. These are my nodes. Let me connect them using my cable. So I'll connect this to laptop. Alright, so when you look at this, this is a star. This is a typical example of the star topology. So let's go back to our slides. So basically this is how it looks like. Every single host on the star topology has its own dedicated connection to the hub. The hub ensures data flow. It can also act as a repeater. Thus, the hub or switch is a device on the network. That is, it receives and sends data to other hosts on the network, wherever that might be. So, the central device here receives. If there is a request here, then the central device will send the data, like we have here. If I'm to send data from this PC 0 to PC2 here, I'll send it through the switch, which is the central server here. Then this PC2 will have access to whatever data I'm sending to it. So that is the star topology. Then we move on to the next topology, which is the bus topology. With bus topology, all the devices or hosts are connected to a single cable called the bus. So the cable is what we call the bus. So if a host wants to talk to any host, that is, let's say this computer here wants to communicate with this computer here, they have to get on the bus. This kind of topology, there may be problem with if multiple hosts are sending data at the same time, meaning that there will be a collision. There will be a data collision. It therefore uses what they call the carrier science multiple access with collision detection, that is CSMA ICD. The main function of this carrier science multiple access and then with the collision detection is that it's a media access control or network protocol for carrier transmission. It senses or listens whether the communication cable or shared channel for transmission is busy or not, and defers transmission until the channel is free. So when the channel is free, then it will then send the data. Thus, the collision detection technology detects collision by sending transmission from other stations. So for example, if this computer or device wants to send information to this device, and at the same time this computer is also sending information to this device, the carrier science multiple access or the collision detection device will detect that there will be a collision here. So it will suspend one of the transmissions, and when the other transmission is done, then it will allow the other transmission to also go through. So let's move on to and look at the ring topology. In ring topology, each node connects exactly to two other nodes, creating a circle network structure for signal transmission. So let's take, for example, if you are using a packet tracer, it means that there wouldn't be any need for a router in the central or as a server. I have my computers here like this. I connect them all without any central computer data transmission. So this is a ring. This is a ring. So when you look at it, you can see that the devices are connected to at least two. This laptop here is connected to this and this laptop. The same way they are also connected in different forms, just like in the diagram here. So you have this computer connected to this and this that computer. So the data travels through all intermediate hosts. So if it happens that this computer wants to send data to this, the data has to pass through this computer before getting to this. In the same way, if this computer wants to send data to this, it has to pass through either this way or this way before it will get to its destination. Alright, so this structure forms a ring, hence the name ring. topology. To connect a host in an existing structure, the administrator may need one more extra cable. So basically, like this, if I want to connect another device here, I'll just disconnect this cable, look for another cable, add another node. That's basically what they are referring to. So I will add another node or device. Already I have one node, I have one cable that is connected already, which I just removed. So I've added one node with one extra cable. Now let's look at the other examples of network topology. We have the mesh topology. In mesh topology, each device is connected to every other device on the network through a dedicated point-to-point link. So simply put, in mesh topology, every host machine is connected to multiple devices on the network. So we have this computer or device here. It is connected to this, connected to that, connected to that, connected to this. And in this sense, we may say that it's a many-to-many relationship, as many-to-many connections, or one-to-many, in whatever way you define it. But basically what it means is that this device here, or one device on the network, is connected to several other devices on the network, and vice versa. Now the next topology that I'll look at is the tree topology. The tree topology, also known as the hierarchical topology. This is the most common form of network topology in use presently. The topology is sometimes called a combination of bus and star topology. This is because it imitates as a standard star topology and also inherits the properties of the bus topology. So this is a diagram. This topology divides the network into multiple layers. So if you look at this, we have the first layer, we have the second layer that is made up of this switches or routers, then the third layer that is made up of the computers or the nodes. So the first layer, which is made up of the computers or the nodes, is the lowermost among the three layers, and we call it the access layer. And this is where the computers are attached. We call it the access layers, these ones. Then we have the second layer, which is called the middle layer, or which is the middle layer, also known as the distributed layer. It works as mediator between the upper layer and then the lower layer. Then the highest layer is known as the core layer. So this is a core layer, and a central point of network, that is the root of the three from which all nodes works or takes their data from. So let's assume this is the server, or this is the main server, and these are intermediate servers. So before you be able to access information from here, you have to pass through this middle layers here, which you call the distribution layers. So the distribution layers will pick the data from here, from the main or the highest layer, which is the core layer here. Pick the data from here, then distribute them to the access layers, and that is the computers or the nodes that are found on the network. So that is the three topology. Then look at the hybrid topology. The hybrid topology. You know, a hybrid means a combination of two or more different breeds. But in this sense, we are talking about network. So a hybrid topology is defined as a network topology that combines two or more different network topologies. So if you look at the diagram very well, this is a ring, This is a bus topology, and this is a star topology. And these topologies have been linked together to form a hybrid network, and that is what we call the hybrid topology. Network sections consist of a configuration of different types of network topologies. The structure of the hybrid topology is more complex, but offers various advantages such as flexibility and then fault tolerance. So it's very flexible, it's very easy to get data or access information regard to the hybrid topology as to that kind of network. Now let's do a recap of what we've learned so far. We've come to the end of the session. Let's look at what we've learned so far. We've gone through 3 sessions. We look at a computer network, and we defined it as a system that connects 2 or more computing devices for transmitting and sharing information. We also looked at the types of network based on size, topology, and then we look at media type. Then we look at a network topology, which we said is arrangement of computer systems. We went through the star topology, the ring topology, the bus, the mesh, the tree, and then the hybrid topologies into details. I'll leave a review questions in the comment section. You go through it to test how well you've understood the concept. Alright, before we go, let's take a look at some few questions, past questions on computer network, and what is being expected of students as to how to go with regards to these questions. So look at question 1 here. This is a 2017 past question. Say, what is physical topology with respect to computer networking? Then question 1b says, identify the following networking topologies. So here we're talking about physical topology with respect to computer networking. So basically, what are they asking? They are asking you to explain the concept of physical topology. Question C went on further to ask about the explanation of the topologies identified in 1b. So you look at this topology, what is it? So a good number of students may answer this correctly. Physical topology is the arrangement of computers or nodes on a computer network. That's basically the definition, as simple as that. And then with the identification, we look at I. What kind of network topology is this? This consists of a bus topology. We also have the star topology here, and then the ring topology. So basically, they are all connected too. So basically, this is a hybrid topology. Look at this. What kind of topology is this? This is a bus topology. Most students defined or explained the topology as a comprising of a bus, a star, and ring topology, because basically when we look at the hybrid, you can find the star, the ring, and then the bus, which is not the best way to answer it. You define the hybrid topology as a combination of 2 or more primary topologies, or a combination of 2 or more topologies to form a new network. The bus topology is a type of topology of physical arrangement of computers in which the nodes of the computers are connected to a single cable called the bus. Now let's look at 2021 past questions. Now with the 2021 past questions on computer networking, you look at question 3. That is a question that is asking questions based on computer networking. State 1 characteristics of each of the following network types. So you have the local area network, the metropolitan area network, and then the wide area network. Then 3b says identify the types of networks shown in BIII, and then IV, shown by the diagrams here. So taking a look at this method of a candidate. For the A, we're just talking about the characteristics of each of the networks that we have there. Local area network, and these are the characteristics. You can go through them. Full-time connectivity to local services, general lower in cost than 1. They allow communication limited geographical area. The transfer of data is very fast. Look at the characteristics of the metropolitan area network. It's not generally owned by a single organization, as we discussed area. Its geographical scope falls between that of the local area network and then the wide area network. It is a large computer network that spans a city or metropolis. And then we have other characteristics there. Then you look at the wide area network. Covers a wide area, allow communication in an unlimited geographical area. They connect multiple LANs located in same or different cities, and then they are usually slower than LANs because the size is very large. Transmission media and connections are managed by a third-party carrier like a telephone company. For example, in Ghana here, our network operators are the main managers of this kind of. Now look at the B, the I. What kind of network is that? For this, I'll leave it for you to identify them as a review question. And then in the comment section, I'll leave some review questions there for you to try your hands on them. Well, congratulations, we've come to the end of this course. Hope to see you in another course very soon. Don't forget to subscribe and leave comments. Let's discuss. See ya. Bye.